Hi folks, we're going to take a look at the solution to number 15 on page 47. So they give us some information on a couple of limits, and then they're asking us to evaluate these two other limits. So first thing is they want us to determine the limit of this function g of x as x approaches 0. So I'm going to work with this piece of information since that's the one that involves g of x, and I notice that the limit of this quotient is equal to 2. So it means that this limit exists. However, I notice that the denominator is approaching 0. Okay, and so we know that the only way for such a limit where the denominator of a quotient is approaching 0 to exist is if the numerator is also approaching 0. Okay, so we have a situation where we have a whole. Okay, so here we can say that since the limit as x approaches 0 of x is equal to 0, then the limit of that numerator function, in this case here g of x, is also equal to 0. Okay, since the limit of the quotient, g of x over x must exist. Okay, so the only way for such a limit to exist where the denominator is approaching 0 is if the numerator also approaches 0. Okay, now notice here, I think they asked a similar question in number 14, which I'd also assigned. Similarly, we can also say that the limit of f at x approaches 0, because we've got the same scenario. F at x over x approaches 1, so that means the limit exists, and since the denominator approaches 0, so does the numerator. So I'll just put this in brackets here, okay, that the limit of f at x as x approaches 0 is also equal to 0, okay, by the same argument. The reason why I'm finding this is because I look at b here, and I've got the limit of this quotient, and I just found out that the denominator is approaching 0. Okay, so the only way for this to possibly exist is if the numerator also approaches 0. So we figured out that the numerator must also approach 0. So this approaches the indeterminate form 0 over 0, which means the limit might exist or might not exist. Okay, so one thing I cannot do is I can't split this up into a quotient, the limit of f at x divided by the limit of g of x, because the limit of the denominator is equal to 0. I can't use that property when the denominator approaches 0. Okay, so I'm going to have to somehow use these two pieces of information that I have. Okay, but I notice here I've got f at x divided by x. I also have g at x divided by x. So the trick here is I'm going to take this quotient and I'm going to divide both numerator and denominator by x. Okay, now why is this allowed? For a couple of reasons. First of all, I'm allowed to divide the same expression to both the numerator and denominator without changing its value. Okay, the other thing that we have to keep in mind is here x is approaching 0. So remember, when we're talking about limits, we don't care about what happens at 0. So since x is only approaching 0, I can do this. Since x is not equal to 0, there's no problem with dividing it to both numerator and denominator. Now the reason why this works is that now I have a quotient where both of the limits exist. Okay, so now I can use my limit properties. Okay, so this is also a question of using the limit properties. I can split this up into the limit of f at x over x divided by the limit as x approaches 0 of g of x over x. Now I should justify this. Okay, number one, okay, both limits exist. Okay, that's given to me in the initial conditions. Okay, so I can only use these limit properties if both limits exist, and very importantly, the limit of the denominator is not equal to 0. G of x approaches 0, but g of x divided by x approaches 2. Okay, so the reason why we're allowed to do this is because both limits exist and the limit of the denominator is not equal to 0. And so now, because I was able to split it up into these two limits, so I know the limit of f at x over x as x approaches 0, that's equal to 1. And I know the limit of g of x over x as x approaches 0 is equal to 2. And so there's my final answer. Okay, so just to recap, this very important idea that if I've got a quotient where the denominator is approaching 0, the only way for the limit to exist is if the numerator is also approaching 0. So I had to use that in A. And in B, I had to be very careful as to when I could actually use my limit properties. I couldn't use them here because the denominator was approaching 0. But once I did this little algebra trick, I was able to use my limit properties because the limit of this denominator did not approach